Year 1815. The sky darkens. A haze of dust wraps the planet. The source? A remote giant. Mount Tambora. The blast was monstrous, 80 cubic kilometers of rock hurled into the air. 100,000 lives erased. The deadliest eruption in recorded history. But even this only a glimpse. Because Earth hides something far worse, supervolcanoes. The ancient monster Toba in Indonesia blew out 50 times Tambora's power, 30 times more debris. An event like this today? Civilizations shredded, populations collapsing, 1 billion lives gone. There are 20 of these titans still alive, silent, waiting. And they're a bigger danger than the asteroids we fear from space. But maybe there's another path. What if, instead of waiting, we could steal their power? NASA engineers have floated an idea. Drill. Inject. Control the fury. Boreholes sink kilometers into the crust surrounding the magma chamber. Cold water injected down. Superheated, brought back up. Steam becomes power. Magma cools ever so slowly. It's walking a razor's edge too close, and you risk triggering the beast. Do it right, and we capture a firestorm for clean energy. Do it long enough, and perhaps, maybe, the chamber freezes. But supervolcanoes aren't the only enemy. The Earth itself is restless, its mantle, its skies, its seas. Every layer carries hidden knives, and our survival hinges not on fear, but on mastery. Music. Mount Pinatubo tears open and releases 20 million tons of sulfur dioxide skyward. A veil forms. Sunlight dims. The planet cools. Global temperatures sink 0.5 degrees. Sea level rise stalls for a decade. Accident? No. Inspiration. Scientists wonder, what if we could copy it? Artificial volcanoes. Spray sulfur into the stratosphere. Block the sun like a planetary sunscreen. An ounce of sulfur dioxide up high equals the cooling power of tons of carbon taken out. Instant relief. A bridge of time bought. But the dangers are sharp chaotic weather, crop failures, nations scrambling for control of the sky. A climate war waiting to happen. Music. Others look past the air. They look to space. MIT imagines a solar shield. A floating wall of silicon bubbles at the exact balance point between Earth and Sun. It would cut sunlight by just 1.8%. Enough to reset the thermometer back to pre-industrial times. But it must be colossal, thousands of kilometers wide, as vast as Brazil itself. Some dream of space mirrors bending beams of light, dialing planetary heat up or down at will. Music. Meanwhile, on the ground, something else grows. Forests built not by nature but by us. The Great Green Wall across Africa, a 5,000-mile belt of trees. Stopping deserts. Feeding soil. Feeding people. Pulling down 250 million tons of carbon. And employing millions in the process. The Amazon, too, must endure Earth's lungs, balancing all we do. But nature alone may not be enough. So we engineer new life. Plants retooled to grow 40% faster. Microbes trained to make electricity from waste. Algae reborn to spit out clean hydrogen fuel. And perhaps the strangest revival, the woolly mammoth stitched back from genes. Herds crossing the Arctic, tamping down tundra, locking trillions of tons of carbon in frozen ground. Life redesigned to protect life. The future may not be metal or steel or circuitry. It may be leaf. It may be cell. Music. Carbon capture takes on mechanical form. Artificial trees. Each machine equals 1,000 real ones. Carbon plates drink in CO. Trapped. Buried. Recycled. 100 million could erase human emissions completely. The oceans too ache under carbon. Growing acidic, shattering food chains. The boldest idea? Blow up the seabed. A nuclear detonation 5 kilometers deep cracks the rock, pulling centuries of CO from seawater. The explosion would dwarf Tsar Bomba, but hidden beneath crushing pressure, fallout might be contained. Geoengineering at its most extreme, insane, yet possibly vital. Closer to shore, gentler fixes arrive. Artificial reefs built from old ships and rubble. Fish populations multiply. Coral thrives. Carbon sinks expand. And reefs stand as walls, shielding coasts from storms and waves. And still the poles melt. Thwaites Glacier, the Doomsday Glacier, cracks under warm currents. Its collapse could raise seas by 10 feet. What's the counterplan? An underwater curtain. A 100-kilometer wall to block the warm currents, to save miles of ice from sliding into the sea. At the top of the planet, Arctic ice fleets winged pumps, spraying seawater to rebuild frozen layers, polar umbrellas shading the sun while creating new ice. Music. But solutions this grand demand energy. Unthinkable energy. Our appetite grows uncontrollably. 2 centuries of exponential growth. 7,000% more energy consumed. 100-fold bigger economy. And climbing still. Solar could cover it. Just 0.3% of Earth blanketed with panels enough for all. Deserts will be the front line. Solar megafarms stretching across the Sahara. Strong enough to produce 4 times current global power. But covering 20% of the sand risks shifting weather patterns, twisting climates around the poles. And beyond raw energy lies a darker truth. Waste heat. Infinite growth on a finite world is impossible. At some point, the planet cooks no matter how clean the power is. To survive, we must expand outward. Music. Orbital solar farms. Floating in constant sunlight, beaming power to Earth as lasers or microwaves. Heat vented harmlessly into space. China drafts plans. Oxford sketches Cassiopeia, a solar array kilometers wide. Step 1. Beam the power down. Step 2. Take industry itself up. Because if factories, servers, smelters churn in orbit, then the Earth can finally breathe. To get there, we need a stairway, a space elevator. Imagine a tether 36,000 kilometers long, anchored at the equator, counterweight in the void. Trains crawling skyward, hauling cargo cheap, safe, steady. 50 times cheaper than rockets, opening the orbital economy. But it can't exist, not yet. We need materials stronger than anything on Earth today, and risks remain deadly space debris. But AI defense nets laser sweeping micro-junk, catching bigger shards, could shield the system. Beyond that, a bolder dream, an orbital ring. a glittering necklace wrapping the planet at 200 kilometers high. Platforms floating above the spinning girdle. Skyscrapers hanging into the sky. Research hubs. Spaceports. Cities suspended in orbit. Multiple rings could crisscross the sky, turning Earth travel into near-instant leaps. Some rings connected to the moon, others vast enough to shade the ground below for hours. A true crown of civilization, built with asteroid steel, kept aloft by constant control. Not a fantasy early prototypes could cost under $10 billion. And in the centuries ahead, it could become the skeleton of our future. Music. Energy captured in orbit. Industry moved outside Earth. Earth preserved as sanctuary. Civilization expanded into the heavens. Music. Heat. 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 Not just to fear, but to command. Music. Heat becomes survival. Heat becomes future. Music. Applause.